Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look again at the creation of game utilities, with our game map by adding territorial boundaries. This was our application at the end of the last video. We have created a terrain map. This can be loaded by clicking on the graphics control, which is the world map. This then displays the terrain map in a larger graphics control, and we can progress the game by clicking on Process Turn. This will position all the rulers on the map. We have at the moment 50 rulers set up in the game. Clicking Process Turn once more will move the rulers around the map and let them attempt to gain territory. We have another button on the screen which is the Process Bulk Turns. This is designed to process sequentially a series of turns. Currently we have this set up to process 100 turns. So let's have a look at the code and see how we can do this. If we have a look at the callback function, the event handler, which is triggered when the user clicks on the Bulk Turns button. And here is the section of that callback function. Our first task within this section of the code is to disable the Process Turns and Bulk Turns buttons, as the computer will be busy processing the request, and you don't want the user clicking on the button a second time before the first set of processing has completed. So we can do that quite easily by using the control disable command, specifying each of the buttons we wish to grey out. Now all we need to do is a for next loop. There is already a routine called Process Turn, and all we're going to do within this for next loop is to call that routine once for each iteration of the loop. The Bulk Turns constant is currently set to the value of 100, and we call Process Turn by passing its three parameters: the dialog handle, the handle of the large graphics control, and the current turn number. And we're giving it a slight delay of 100 milliseconds before we do the next iteration of the loop. Once that loop has completed, we can then re-enable the Process Turns and the Bulk Turns buttons. So with this small amount of code, we've now enabled the Bulk Turns button. Let's run the application and see how it performs. We click Process Turn for the initial turn, then after that we can click on the Process Bulk Turns to let it step through 100 turns. And as we can see, it's moving all the rulers around quite happily. However, although the rulers are moving around, we're not actually seeing which territories they actually control. There's nothing on the map to indicate where one territory is aligned to another territory and owned by the same ruler. That's what we need to do next. So let's get back to the code. If we now have a look at the Process Turn function. The Process Turn function performs all the calculations and the moving of our rulers. At the moment, we're doing this update rulers on map. There are additional functions we'll need to slot in here. The next one is going to be the update territories. This new function is going to redraw the territorial borders and needs no parameters. So as you can probably guess, we're going to step through each of the territories on the map. So we're going to have a nested for next loop. And we'll need, again, some local variables to allow us to keep track of all of this. As we did in previous functions, we're going to determine the size of our graphics control by using the graphic getSize command. And we will use the output from this command, the width and the height, to work out the size of each territory on screen. And now we'll do our nested for next loop. Within this loop, we need to work out what kind of terrain we're talking about. So we're going to delve in, again as we did before, to pick out the terrain type from the map array. And as we are only interested in land masses, if it's a 0, that means the terrain is C, so we can ignore that. Next we want to get the ruler who is the owner of that territory. If the ruler is 0, then the territory is not owned by anyone. And if that's the case, we need go no further in this particular loop because the territory not being owned will keep its existing borders. Next we have to check if the ruler is now inactive. In other words, has this ruler been killed off? And if they have, then the ruler's claim to the territory is null and void. So we can test the rulers array to see whether the active flag is 0 or 1. If it's 0, then we can clear the territorial ownership of that on the owner map array and move on to the next territory. If we've got this far, then the territory must be owned by someone. So we now need to work out the borders on all 4 sides of this particular territory. So we're going to store the top left-hand coordinates of the territory we're currently looking at. This is a straightforward piece of arithmetic, taking the x and the y coordinates, subtracting 1 from each of them, and then multiplying by the size of our territory. This gives us the pixel coordinates on screen, within the graphics control. So we have to check each of the terrains, to the left, to the right, above and below. First of all, we'll do the one to the left of the territory we're currently in. We can work this out quite easily by subtracting 1 from the x coordinate. And then we're going to call a new function called checkTerrain for ownership, passing it the owner of the territory we're currently in, the coordinate we want to actually check, the x and the y, and then if that returns true, then we can redraw our border. If this returns true, it means the territory to the left of the one we're in is owned by the same person that owns this current territory. So we're going to redraw the graphic line in a green colour, effectively wiping it out. So let's create this new checkTerrain for ownership function. And here we have the skeleton of our new function. The first task within this new function is to determine if the x and the y coordinates we're looking at are outside the boundaries of the map. Are they 0 or greater than the map width or map height? If that is the case, then the territory we're trying to look at is off the map. Therefore, we can return false. Next, we have to test to see whether the map array has this particular terrain as 0 or 1. If it's 0, we're not interested as it's a C terrain. Therefore, if it's map, we can then check to see whether the owner of this terrain is equal to the owner of the terrain we're coming from. If that value matches, then we're returning the value true for the function. If not, we'll return false. And that completes the logic in this function. So we can go back to our calling routine. So now that we've checked the terrain to the left, we have to do exactly the same calculation for the terrain to the right, the terrain above, and the terrain below. So we will paste in the code to do these. So the entire logic of this routine is to check the ownership of the terrains surrounding the terrain we're currently in. If they all have the same owner, then we can effectively wipe out the borders. So we're on the application now to try our changes. We can load our world map and click on Process Turn. And if we click the Process Bulk Turns to give us 100 iterations of the turn processing, we can see that the rulers are moving around the map. And as they move around the map, they are attempting to gain new territory. And we can see, now that it's completed 100 turns, we can see the borders have been wiped out and we can see the extent of each little empire. At the moment, the rulers are only occupying and owning territories where the terrain currently has no owner. So we can now move on to the next stage, which involves battle simulation. In order to do this, we need to look again at the Move Rulers function. This function is designed to move rulers around the map. And there is a section which determines if the terrain is already owned. If the terrain is not owned, then the user just moves into it and becomes the new owner. So now we have to populate the case where it is owned by someone else. So first of all, we need to pick up who the previous owner actually is, looking at the owner map array. So we will populate a variable to contain the number of the previous owner. And we're going to have to create a new routine called Battle1. This routine will return true if the ruler who has attempted to move into this territory has actually won the territory in battle. So we'll create that routine in a moment, but first we'll push on with the code within here, on the assumption that the ruler has actually won the battle. If that's the case, we can update the ruler's location to the location of the terrain we're moving into. And we can also mark it as owned and increment the ruler's power, the number of territories they currently own. And if the battle has not been won, we won't move the ruler into it. We'll leave the ruler where they currently are. So now we can look at creating and populating our battle won function. So in order to determine who wins a battle, there has to be some logic in here, working out which of the two rulers is the more powerful. So we're going to create a couple of variables to work out how many points the defender and how many points the attackers actually have. And is the defender themselves actually present in the terrain that's being invaded? And in addition to these, we'll need to make some kind of adjustment for the number of victories or defeats each of the rulers actually has in the past. So we will populate our defender power points and our attacker power points based on the number of territories that each of the rulers actually currently has. Next, I will determine whether the defender is actually within the territory or not. If the defender is in the territory, then this should increase their chances of success. So we can test the rulers array for the x and y coordinates of our defenders. And if the defender is actually in the territory, we're going to increase their power points by 10%. Next, we will make some adjustments for previous victories and subtract any defeats, both for the attacker and the defender, and these values will be added on to the power points they have accumulated. So if the attacker's power points are greater than the defender's power points, then we will reduce the territories owned by the defender by using the decrement command to decrement their power value in the rulers array. And we will increment the number of defeats by the defender and increment the number of victories by the attacker. If at this point the defender's power is down to 0, in other words they have no territories left, then the last territory has gone, so we will mark the defender as inactive. Additionally, if the attacker has won and the defender was present in the territory, we're going to mark the defender as being eliminated. In other words, we will make them inactive. And we will return true to the calling function. And if the defender themselves have actually won this battle, then we will increment the number of defeats by the attacker and increment the number of victories by the defender, and return the value false to the calling function. Now that we've completed our battle routines and updated the territories, there's another two functions we'll need to call. First one is a check on the territories owned by the rulers. And the second routine to complete this section will be to update the ruler count on screen, as some of the rulers may have been made inactive and you want to reduce the number of rulers shown on the front screen to the user. So let's look at the check ruler territories first. This is a check on the number of territories owned by rulers to ensure that the count is actually correct. So as you can guess, this is another for next loop. So within this loop, we're testing the active property of each of the rulers. If the ruler is currently inactive, then they should have no territorial power. So in each case, we're ensuring this is containing the value 0. If the ruler is still active, then we want to recount the number of territories owned by them. So we will drop into another new function whose job it is to count these up, passing a single parameter which is the owner number. And again, this is another nested for next loop, looking at the owner map array. Should the owner map array equal the owner we're actually looking at, then we'll increment a count variable. And we will return that count variable to the calling routine. And that will feed into the power value in the rulers array. And the final call within this section is the call to update the ruler count function, which we have previously completed. So let's try running our simulation once more. We can select the world map. We can click Process Turn to process the first turn, and then we will click Process Bulk Turns. As the rulers move around the map, you can see the current number of rulers is being reduced. Each time one of the rulers is eliminated, the screen will be updated to say the current rulers. So we've now lost 3 of our rulers. If we process it once more, we can see their rulers are increasing the size of their territories. And in the process of doing that, some of the other rulers are being eliminated. So what we've achieved today is we have enabled the Process Bulk Turns button to allow us to execute 100 turns at a time. In addition, the boundaries of territory are being updated by redrawing the map, eliminating the boundaries between territories. This on screen gives you a nice display to show you which territories are bigger than others. And you can easily see which territories have not yet been owned by anyone. Additionally, we have added some simple battle routines, working out the strength of both attackers and defenders. These are very simple routines, but they do give you a good simulation. Hopefully you'll find this type of code interesting, but that's it for today. Thank you for watching.